Now let's proceed to the Isohyetal method, which is the third possible method in converting point rainfall into aerial rainfall. So, um, the let us say that this is the basin boundary, this one, and the isohyets are or isohyetals are these lines. So this is somewhat similar to a contour map, but instead of the terrain, it presents the depth of rainfall. So for example, this isohyetal here is 8 centimeters of rainfall. This one is 10, and this line here is 12, and so on. So also these dots are the different stations with the rain gauges. So let's try to solve this one. So we have zone 1, which is less than 6 centimeters. So we can write here less than 6. For zone 2, that is between 6 to 8 centimeters. Zone 3, that is 8 to 10 centimeters. And then for zone 4, that is 10 to 12. Zone 5 is greater than 12. And then zone 6 is less than 8. So let's now proceed to the mean isohyetal value. So usually this is taken as the average of the isohyets. So for zone 2, which is 6.8, we have 7.5. 7, sorry. So from 6 to 8, we have 7. 8 to 10, we have 9. 10 to 12 is we have 11.0. So how about if the isohyet is less than 6, greater than 12, and less than 8? So in the reference I am using, they simply took the mean isohyetal value as the average of the two rain gauges here. So we have 5.4 for zone 1. We have 12.9 for zone 5, and we have 7.5 for zone 6. But sometimes the mean isohyetal value is given in the problem, but usually it is taken as the average of the two successive isohyates. So, if you have encountered a problem that, for example, the given isohyet here is 8 and there are no rain gauges in the figure, you can simply set it as a number a bit smaller than 8 centimeters, such as 7.5. But in this example, 7.5 is obtained by averaging um, rain gauges O and B. So now that we have the mean isohyetal value, let's now get the total area of the basin. So this is equal to 7,180 square kilometers. So the next step is to get the product of the mean isohyetal value and the area between the isohyets. So 5.4 times 410, this is 2,214. Next is 6,300. Next is 25,650. 19,250. And then 9,288. 9,288. And then 4,125. So you will have to get the total, which is 66,827. 6,827 kilometer squared centimeter. So in order to get the average precipitation in the area, this is simply the P average is equal to the summation of the product of the mean isohyetal value and area between isohyets all over the total area. So this is 66,827 kilometers squared centimeter all over 7,180 kilometers squared. So this is equal to 9.31 centimeters. So what did you notice in using the isohyetal method? So the concept of the isohyetal method is somewhat similar to that of the Thyssen polygon. Kasi we are considering the area between the isohyets here, and in the Thyssen polygon, we are considering the influential area of the respective stations. So If this is performed well, the isohyetal method is the most accurate method in determining the aerial rainfall by using point rainfall measurements.